This is an introduction to the Microchip Technologies 7-bit single I2C digital potentiometer. Welcome to the training module on the MCP 40D17 digital potentiometer. This training module introduces the working principle of the digital potentiometer and its applications. The MCP 40D17, 18, and 19 devices are general-purpose digital potentiometers intended to be used in applications where a programmable resistance with moderate bandwidth is desired. The devices offer a wide range of product offerings using an I2C compatible interface. This family of devices support a 7-bit resistor network, volatile memory configuration, and potentiometer and rheostat pinouts. This device family is offered in miniature 5 and 6 lead SC70 packaging. Common applications include power supply calibration, audio volume control, brightness control, gain adjustment, and control of bias and modulation currents in optical modules. These devices are extremely useful in the modern digitally controlled world, but have some limitations. While quite similar to a normal potentiometer, digital potentiometers intended to be used in applications where a programmable resistance with moderate bandwidth is desired. Digital potentiometers, or DIGIPOTs, facilitate digital control and adjustment of resistances, voltages, and currents in analog circuitry. This 3-terminal DIGIPOT configuration is essentially an adjustable resistive divider with a fixed end-to-end resistance. A mechanical potentiometer has 3 terminals with VL connected to ground, and in the digital potentiometer there is a wiper resistor, VW, connected between ground and a variable point. The digital potentiometer device has 3 main functional blocks. These are the serial interface, the system control, and the resistor network. There are 3 common serial interfaces. These are a simple up/down interface, the SPI interface, and the I2C interface. There are a number of features that can improve system performance and simplify designs. Among these features are various types of non-volatility, zero crossing detection, debounced push-button interfaces, temperature compensation, and write protection. The I2C interface adds some complexity to the host controller firmware, but allows the interface to be as few as 2 pins while still being able to read and write to the device. Multiple devices can easily be added to the bus, and due to the open drain outputs for the clock, SCL, and data SDA signals, all master devices can initiate serial communication. Address pins are used to differentiate multiples of the same device being used on the I2C bus. The I2C interface also has better noise immunity than SPI and the U/D interfaces. The MCP 40D17 is a true rheostat with terminal B and the wiper W of the variable resistor available on pins. The resistor ladder is a series of equal value resistors, RS, with a connection point tap between the 2 resistors. The total number of resistors in the series ladder determines the RAB resistance. Digital potentiometer applications can be rheostat configuration or potentiometer or voltage divider configurations. The resistor network has 127 resistors and a string between terminal A and terminal B. This gives 7 bits of resolution. When used as a rheostat, 2 of the 3 digital potentiometer terminals are used as a resistive element in the circuit, with terminal W wiper and either terminal A or terminal B. A variable resistor is created. The resistance will depend on the tap setting of the wiper and the wiper's resistance. The resistance is controlled by changing the wiper setting. When used as a potentiometer, all three terminals of the device are tied to different nodes in the circuit. This allows the potentiometer to output a voltage proportional to the input voltage. This configuration is sometimes called a voltage divider mode. The potentiometer is used to provide a variable voltage by adjusting the wiper position between the two endpoints. Reversing the polarity of the A and B terminals will not affect operation. The typical application will require a bypass capacitor in order to filter high-frequency noise, which can be induced onto the power supply's traces. The bypass capacitor helps to minimize the effect of these noise sources on signal integrity. Applications that need accurate detection of an input threshold event often need several sources of error eliminated. Use of comparators and operational amplifiers, op-amps, with low offset and gain error can help achieve the desired accuracy. If the application has to calibrate the threshold of a diode, transistor, or resistor, a variation range of 0.1 volt is common. Often the desired resolution of 2 millivolts or better is adequate to accurately detect the presence of a precise signal, a windowed voltage divider. The MCP 40D17, 18, and 19 devices can be used to replace the common mechanical trim pot in an application where the operating and terminal voltage are within CMOS process limitations. The thermistor calibration utilizes a digital rheostat for trimming the offset error caused by the thermistor's part-to-part variation. Both are simple voltage dividers using a positive temperature coefficient PTC resistor, R1, with a transfer function capable of compensating for the linearity error in the negative temperature coefficient thermistor. This solution puts the digital potentiometer's RW into the voltage divider calculation.